Now we'd like to start the session again, and we're very happy to join by Mr. Ishii. So he was a member of mruby development project supported by METI, and he has been focusing on the spreading mruby, and also he worked for IoT platform as commercial product using mruby as his capacity of the members of the embedded program department of SCSK Kyushu. And also he's a great fan of the music. He also plays instruments, the bass guitar and keyboard as a member of the Led Zeppelin tribute band. And also he played the music on stage as musician as well. So he's going to give the presentation, the easy IoT for everyone, a hidden story of the IoT platform developed by mruby and mruby/C. Thank you very much. I'm Ishii. So now I heard the word Zeppelin. So here's the picture. Do you know Osama? Osama is a musician who sang the music, a song, translated in the Japanese lyric, and this is a picture on the right-hand side. That was me. I played with him. So here's my capacity. So the mruby is a lightweight Ruby. So you can run Ruby where the resource is quite limited, so that's mruby. Initially, it was a code name, and then now we also support this as NPO. I'm the member of the secretariat of lightweight the Ruby. So what we do in this MBO is to do the debugging mruby so that the small medium companies can also use Ruby with limited resources. So I'm going to talk about the history and how we have developed the mruby and developed the IoT using mruby. So the initial idea was that maybe mruby is quite suitable for IoT. So here I'd like you to take a look at this. But perhaps you feel the IoT is quite a daunting task because the hardware, the network, and also the cloud, you have to have the knowledge of all these areas. So mruby was developed for the embedded program for the web people, but I2C and debug and the serial and also the spec and the PCBs and the device. So these knowledge is the weak area for the web people. And however, those are the people who have the lots of knowledge about the hardware or the machine themselves has a limited knowledge of the web service. So I wanted to cross this gap so that it would be useful for all these people. And also there are many application specific use for IoT. For example, the monitoring the levels of the river and the breakdown of the machine. But for our development, I wanted to develop some application easier to use for many people. And this is what we built. We built this in 1 year, and it was supported by the Kyushu University College of Technology and Ariake Technological School, and also NEDO and GigaFarm. So we have been developing a system as a consortium, and we opened the platform. So here, I'd like you to see the Wi-Fi, Zigbee, So the daughter board, so connected to the microcomputer. So here the microcomputer port, and here's a menu. So you don't have to write codes. You just send the server data to server and notifying if. But you cannot bring this to the field, and also the job was limited to only one. So that was our initial trial, sort of prototype. So we wanted to have the versatility because the real IoT would be in a very difficult condition. You may not have the power cable, you may not have the access of the Wi-Fi. So the battery operated the system may be required in the middle of the city, and in particular outside the city. So we thought about the long-range version of the Bluetooth technology became available by Fukuoka company. Then now you're using earset, that's Bluetooth 4. So the Bluetooth 5 is a long-range version, the communication over 100 meter, and consumed a very small amount of power. So we thought that this technology would be the kind of breakthrough. So we wanted to build the IoT platform, which is really usable, based upon our prototype I showed you earlier. So here the edge device. The various sensors are attached, and here's a Bluetooth long-range version covering 100 meter to 1 kilometer range, and then receiving here, bridge device, and then the long-range wide area sending to the internet, LoRa, using LoRa 1. So 16 to 20 units of this have been used. I have the actual sample. This is the actual size, the battery operated, and also chargeable. So for this system we developed, well, this is a hardware, but if you just have this hardware alone, you can't do much. So we had to write application as well. For example, if the temperature reaches such and such degree, this is an action, something like that. And we wanted to make it user-friendly so that a user can do all these things without writing the codes. And we wanted to publish this as the platform. And our idea was adopted by the support industry. And the Rwc is the company in Fukuoka who's quite strong with the technology. And we worked with the same group of people who work on a plateau at the Kyushu Kogyo University, and also SCSK Kyushu and IOC, and also Fukuoka East. This is the organization who served for the general application of the IT. And with those people, we build the IoT platform. So that's the story I'd like to share. And what we used was Nordic NRF 52840, and this is a Bluetooth long-range version, and can be operated with the ARM Cortex-M4 and also the other ROMs as introduced here. And also as for the RAM, the 256 KB was a bit challenging area for mruby. And this is a list of peripheral device we used, various sensors. And as for the edge, those sensors were attached. And for bridge, the bridge device receiving the 5.0. So this bridge, we use the LoRa module. And we changed the specification on the halfway of the project and attach a GPS. Because an IoT uses GPS technology very, very much. So we wanted to have this LoRa, the module, so that the bridge can operate with GPS and all battery operated. And now application. So we adopted drag and drop approach. So here are all the sensor menus, and there are 3 jobs. So you can set multiple jobs, and you control job with job, like the job 1 success, and then job 2, and so on and so forth. And software, soft device S140. This is a common for edge and bridge, and this is the basic of the Nordic. And as for the edge device, where the sensors are mounted, we use the mruby sensor, the VM. And also the LoRa bridge, we also use the system as given here. And as for the application structure, and to run the IoT job, we need the 3 component sensor timing action. So as you see on the top right, so you select the sensor. This is the pressure, and also acceleration, direction, and the battery, whatever. And then next selection is about timing. There are several options. For example, every certain seconds action, or at certain time some action, or the when to start and when to finish, or trigger events. For example, if the sensor reaches 30 degrees Celsius, a job starts. Action starts, and then as for action, the when's done, it should be sent by Bluetooth, and here's the on and off. So you turn on or off the previous job, and high or low of the voltage, or you can use what's connected as switch. There are many things you can do. And the generation is automatic, and the application structure is like this. And this is for edge device on the left. So after default, the farm default, and the edge inst RB, that's Ruby's application. And this portion below is where what's mruby/c is really good. So the main process, and then the backend process using the edge BGRB. So this is the concurrent. So mruby is not very good for concurrent the implementation, but the /c is quite good at this, and that is why we have adopted /c. And also there are 2 stages. The first, you start up, and then edge int RB. And the bridge device is much simpler. There are 2 stages only. And this is how we initialize GPS. So this is based upon the specification. So power pin, it's refined, and then we set IO definition. VDD high, that's on, and then chip set, and wait for 5 milliseconds. And setting chip and clear, and wait for 100 millisec. So this is how we do initialization of the GPS, written with a Ruby, mruby. And then as for the hardware, we use this chip, nRF52840, and have the 3 serial interfaces. This is for the LoRa, SPI used with bridge, and then UART for connecting GPS, and I2C, the temperature sensor, and the volumetric pressure, and also acceleration, and also LED controller, where you see the blinking light depending on the battery usage condition. So there are many serial application, many serial attachment, and this is how it appears. By the way, GNSS. So when you GNSS is the global system to monitor the location, and the one kind of GNSS made by the United States is called GPS. And then we have also UART as wrapper, and then we have the classes made by Ruby. And this is a library of the mruby/c, and was not published. So you have the various. We have made the various classes, BLE class and the I2C class, and so on and so forth. These are the classes we needed and we made, and these are the library for edge devices. Other than the LoRa, so all these classes are publicly available on a GitHub. And mruby and mruby/, the both were used, and in doing so, there were some benefits because everything was written using mruby and mruby/c. And also, even with a limited resource like the 256 KB, it worked, and also not dependent on the environment. And the application, the update was easy because it's not dependent on the environment because it's and also the binary interoperable with the binary system.
これスラシーのコンカレント実行機。
So it is possible to describe a parallel operation. The development of a library is easy when you get accustomed to it, so you can just write it. And finally, mruby. If you need to do the real-time control of the hardware, then you will write it with the C language. Otherwise, you can write other applications with Ruby. So if you have some questions, you can use both mruby and mruby/c. If you have doubt, you can use both. And if you use both, you get confused. The library specifications are different. mruby/c doesn't have a gem, and therefore everything should be put into source codes. If you want to change the library, then you need to change the source code as well. So if you separate from VM, it's reusable, and that's why /c is better. And also /c doesn't have any exception processing. And people saying that they are making it. Probably in the near future there will be available, but at this moment error checking is quite frequent and cumbersome. And /c is very good, but different from Ruby. There's no concept of a class method. In other words, everything is done with the instance method. It seems to me that everything is with the instance method. I don't know whether that is true or not. So if you are accustomed to Ruby, this is different, and there's no possibility of using class constant. On the left-hand side is mruby, and very agreeable with Ruby, and this is dignifying. This is indicating the address, and in the case of mruby/c, you have to do it one by one. So this is a difference between mruby and mruby/c. And while working on this, I realized you need to do both to understand this. And I try to make mruby smaller and smaller, but the limit is 200 KB. And mruby/c can be much smaller, but you cannot use over 64 KB. Between 64 KB and 200 KB, the Ruby cannot be used between these. So I requested to eliminate this limit, and also prior to the use of the applications, user-defined library can be registered to VM. That is another improvement. And there are a lot of pitfalls in the application if you do the IoT. Starting from GPS, for instance, I mentioned about initialization, and the power source ping is not controlled. The next one, the board, this is under the test, and the GPS can be taken, but if you go out on a sunny day, you cannot take GPS. This is a quite puzzling. I understand if the situations were opposite, but actually if you go out, you cannot get the GPS. The part of the semiconductor is exposed. That is a CSP package. Therefore, under solar irradiation, it does not function. And this is what happened. And the next one, and the bridge does not connect to LoRa base station. This is a BLE. And I asked to put antenna, and the constant is calculated. This is a proper antenna, and it started to function finally. This is for 4 bands, and the very sort of excellent antenna was put. And the Bluetooth 5.0, that is a long-range version. If you write applications, the PC does not support the Bluetooth 5.0. So you use a 4.0 first, and then verify the operation, and then move on to 5.0. And the board team changed the parts and components so frequently, so the communication is not so properly done. And supporting, that is for 3 years, 17, 18, and 19, and the next year in April this will be finished. But until that time, it's not possible to sell products. Actually, IoT will not be around next year. We are trying to reduce the development period as much as possible and finish within 2 years. And last year, some people wanted to continue the subsidy, but actually we decided to stop after 2 years without receiving the 3rd year subsidy. And now, from top to bottom, you can write in Ruby, and on cloud Ruby, and smaller one mruby, and device mruby/c. And Nedo and Amext and Fukuoka Prefecture, Shimane Software Research Center ISD, and mruby/c is supporting other people. Thank you very much for sending us requests and also the questions. Thanks to all of your contribution, I was able to make this program. Thank you very much. Thank you. We would like to take questions from the floor. Please raise your hand. Yes? Thank you very much for lecture. My question is, in your presentation, in your explanation of LED controller under mruby/c, LED controller, when the battery is scarce, the light would blink, and that is the function to tell the user that the batteries are running down. And it occurred to me that blinking light, lit and unlit, it is like making fist and making extend your fingers. So we get tired, and by blinking the lights, the energy consumption will be larger and the battery will be consumed much faster. What do you think? Yes, exactly. But we want to tell something. For instance, if you use LED, the battery will not be consumed so quickly. Then we are using rechargeable battery. So please recharge the battery. That's why. It's not a specification that would consume the energy so much. Of course, it consumes battery energy, but it blinks, and just for that purpose. Thank you very much for asking questions to all of the presenters, and I will give you the MVP for the person who asked the largest number of questions. Any other questions? If none, we would like to conclude, and you can ask questions individually with a speaker. You showed us the picture of a cat, quite pretty, and I enjoy your way of showing those things in a flexible, playful way.